Most people say AI learns. That word sounds natural. It sounds human. And that's exactly why so many people misunderstand and fear AI. Let's clear it up. When you hear the word learning, you don't think about maths. You don't think about statistics or probability. You picture a student sitting in a classroom. You imagine someone absorbing knowledge, someone forming concepts, someone building an understanding of the world. If that is your mental model, you are already off track. Because with that model, almost everything AI does will be misunderstood. The mistake starts with the word itself. So the first thing we have to do is remove that word entirely. AI does not learn in the human sense. It does not acquire knowledge. It does not form understanding. It does not build concepts. And it does not know what anything means. What AI actually does is fit patterns. It fits the statistical shape of human language. It does not fit meaning. It does not fit truth. It only fits likelihood. In simple terms, it predicts what comes next. It predicts the next word, token, or symbol. It does this based on patterns it has seen before. The better the patterns, the better the prediction. This distinction matters far more than it sounds. Because once you call prediction learning, expectations change. You start expecting understanding. You start expecting judgment. You start expecting reasoning. You start expecting intention. And when those expectations aren't met, confusion follows. When the system fails, it feels like something broke. When it gives a confident but wrong answer, it feels deceptive. But nothing actually broke. The system is doing exactly what it was trained to do. It is predicting the most likely continuation of a pattern. It is not checking facts. It is not reasoning about truth. It is not validating meaning. That is why AI can sound intelligent. It can produce fluent answers. It can sound confident and polished. But it can do all of this without understanding anything. It can explain ideas it does not hold. It can describe concepts it does not grasp. It can sound certain without knowing whether it is correct. Because fluency is not the same thing as comprehension. If you've used systems like ChatGPT, this feeling is familiar. You ask a question. You receive a coherent answer. Sometimes the answer is very good. Sometimes it even feels insightful. In those moments, it can feel like something is thinking. It can feel like there is a mind behind the response. But that feeling is misleading. What you are actually seeing is prediction at scale. This scale is far beyond what humans are used to. The predictions are fast, dense, and statistically refined. That combination creates the illusion of thought. To understand how this happens, imagine a different scenario. Imagine a sculptor trying to recreate a statue. But there is one crucial restriction. They cannot see the original statue. The sculptor is wearing thick gloves. They cannot feel fine details. They can only feel the surface. They make a small change to the clay. Then they compare it by touch to the original. If the change is closer, they keep it. If it is further away, they undo it. They repeat this process again and again. They do this thousands of times. Then millions of times. Each adjustment is tiny. Each correction is mechanical. Eventually the replica becomes extremely accurate. From the outside, it looks like mastery. It looks like deep understanding. But that appearance is misleading. From the inside, it is just error reduction. The sculptor does not understand the statue. They only reduced the difference between two surfaces. The gap between them became very small. That is what training really is. It is not learning. It is fitting. An AI model does not start with knowledge. It starts with randomness. Billions of numbers exist with no pattern. There is no structure present. There is no meaning present. When training begins, the system generates an output. That output is measured against reality. The result is a single number. That number represents distance from correct. It is not an explanation of the error. It is not guidance toward improvement. It is only distance. That distance creates pressure. The pressure reshapes the internal structure microscopically. This reshaping occurs through pure mathematics. The system never knows a mistake occurred. It only experiences force applied in a specific direction. The system does not know it is improving. It does not recognize progress. It does not track how far it has come. The cycle continues without pause. Output is generated. Distance is measured. The structure is reshaped. This process runs millions of times. Then billions of times. In large models, it runs trillions of times. The objective remains constant throughout. Reduce the distance. There is no global view of the process. There is no awareness of direction. There is only local response. What is absent matters as much as what occurs. The system builds no memory of past attempts. It forms no strategy from accumulated errors. It develops no intuition about patterns. Each reshaping is isolated. Each change is triggered only by immediate measurement. Consider word prediction. The model generates a word. If that word differs from the training data, distance is measured. Pressure is applied to the internal structure. That structure shifts microscopically. Nothing inside the system comprehends language. There exists only tension and release. This process has a name. It is called gradient descent. The intuition is simple. A ball placed in a bowl will roll downward. It does not understand physics. It does not seek the lowest point. Gravity acts on it continuously. If the ball encounters a depression, it settles there. This occurs even if deeper points exist elsewhere. This explains training outcomes. Systems find adequate solutions, not optimal ones. They exhibit confidence produced by numerical convergence. That confidence does not reflect certainty. No goals exist beyond optimization. No intent exists behind the output. No meaning exists inside the system. Training ends when humans judge performance sufficient. No arrival occurs. No completion is reached. The process is simply halted. What remains is not intelligence. It is a mathematical structure shaped by measured distances. It is a surface optimized for reproducing statistical patterns. Nothing more. When training is recognized as optimization without comprehension, system behavior becomes predictable rather than mysterious. The scale shift, why it feels like thinking. If training is blind error reduction, a question appears. How does it get so good? How does something with no understanding produce answers that feel thoughtful? The answer is not intelligence. The answer is scale. Early AI systems processed language narrowly. They examined text in small pieces. One word at a time. They could make local predictions. But they could not connect distant information. By the time the system reached the end of a sentence, it had already lost the beginning. Patterns existed. But the system could not see enough of them at once. This severely limited how well it could fit language. Then a structural change occurred. In 2017, researchers introduced a new architecture. It was called the transformer. The paper introducing it was titled "Attention is All You Need." But this did not give AI understanding. It did not give AI concepts. It did not give AI a mind. What it changed was attention. Before this, the system behaved like a penlight. It illuminated one small part of text at a time. After this change, it behaved like a stadium searchlight. It could illuminate the entire context at once. Suddenly the system could see whole sentences together. Whole paragraphs together. Entire contexts together. The training loop did not change. Predict. Measure. Adjust. But the fitting process now operated at a different resolution. More relationships could be adjusted at the same time. More correlations could be captured in parallel. More structure could be matched in a single pass. Nothing new was added conceptually. The system still had no understanding. It still had no goals. It still had no awareness. But the surface it was fitting became far denser. At high enough resolution, surface patterns begin to resemble thought. Human reasoning leaves traces. Logic leaves structure. Expertise leaves shape. Those traces exist in language. Those shapes exist in data. The model does not reason. It fits the shapes left behind by reasoning humans. And when the fit becomes precise enough, the reflection starts to feel intelligent. We mistake clarity for comprehension. We mistake fluency for thought. The accuracy of the mirror is mistaken for a mind. But nothing fundamental has changed. The system is still predicting. It is still reducing error. It is still fitting patterns. Scale sharpened the reflection. It made the surface smoother. It made the patterns tighter. It made the output feel deliberate. It did not cross a boundary. And that means something important. No matter how powerful the system becomes. No matter how much data it sees. No matter how large the model grows. There is a limit it cannot pass. Not because it lacks scale. But because scale does not create understanding. And that limit is where we go next. The wall, data is not understanding. Now we can address the wall directly. People imagine that enough data will eventually create understanding. As if information itself generates a mind. It does not. To see why, imagine a photograph of fire. A low-resolution photo looks vague. You can tell it is fire, but not much more. Now increase the resolution. Add more pixels. More detail. More clarity. You can zoom in. You can see individual sparks. You can see texture in the flame. The image becomes incredibly convincing. But no matter how detailed it gets, it will never be hot. You can add more pixels. You can add more clarity. You can add more resolution. You will never add heat. That is the wall. More data makes the map more accurate. It does not turn the map into the territory. Every AI system in existence lives on the wrong side of that wall. Modern AI models are trained on enormous amounts of human-generated data. That is why they sound fluent. That is why they mirror reasoning. That is why they can write convincingly. Human thinking left patterns behind. Those patterns are what the system fits to. The model does not recreate the thinking that produced them. It only learns the surface. And with enough data, that surface can become extremely detailed. Convincing. Persuasive. Sometimes brilliant. But still just a surface. What we built is not a student. It is a mirror. A mirror with extraordinary resolution. And mirrors do not understand what they reflect. They just reflect it perfectly. This is why modern AI feels so strange. It can write poetry. It can explain quantum physics. It can argue philosophy. Not because it understands any of those things. But because human experts left patterns behind in the data. And the system learned to fit those patterns with extreme precision. The brilliance you see is not insight. It is high-resolution pattern matching. The confidence you hear is not certainty. It is statistical likelihood. The reasoning you sense is not thinking. It is mathematics following the path of least error. And if this way of explaining AI helps things click, not as magic, not as consciousness, but as a system doing exactly what it was built to do, that is what this channel is about. No hype. No fear. Just how it actually works. And remember, AI doesn't think. It predicts.